Welcome back, scholars, to a continuation of our math properties that we're learning of. We're going to now dive into the next set, which is the ones highlighted in red. We did discuss already the commutative property, associative, and distributive. And I'm going to show you a little bit before I dive into the different properties. I'm going to show you a little reason why I did say in the previous video why division wouldn't take place and also subtraction wouldn't take place. So let's do an example. I'll show you the one for commutative and I'll show you one for associative. For commutative, we said that it was simply a simple addition or a subtraction. A simple addition or multiplication, excuse me. It doesn't matter how I'm writing it or which order comes in first, the answer will still be the same. If I happen to do subtraction, the order of the numbers would change the answer. So let's give an example. If I did A minus B, this is not the same as saying B minus A. And the same thing goes to division. If I did A divided by B, it's not the same as B divided by A. I'll give you an example. If we make A 3 and B 5, 3 minus 5 is not the same as 5 minus 3. 5 minus 3 is 2. 3 minus 5, for those who watched the previous video, is negative 2. Negative 2 and 2 are not the same. If I did 3 divided by 5, 3 divided by 5 is not the same as me saying 5 divided by 3. The fractions are completely different. This is for commutative. I will now apply the same logic and the same reasoning with the associative. Associative is commutative with an extra step, simply grouping. This is the correct way we did our grouping. But now let's see what happens when we do it with subtraction. I'll write it in blue for subtraction. If I did A plus B minus C, this will not give me the same answer as if I did A minus B plus C. The answers would be completely different. And this is also going to be applied for division. If I did A divided by B times C, it's not going to be the same as if I did, actually, now let's not do multiplication, let's do addition. It will not be the same as if I did A plus B divided by C. The answer will be completely different. And this is why it only works for addition and multiplication. So we got the hang of that. Now let's dive into our other three properties. The identity property is simple. We want to keep our identity. I'll give a funny little story about it. When you go home and you change your shoes, does your name change? When you go home and you change your haircut, does your name change? No. Simply, identity property means that no matter what I do, the answer will never change, or the property of our real number will never change. What do I mean by that? If we take A to be a real number, any number that we said is one, rational, irrational, or fraction that repeat, but they don't, that are repeating the same number or repeating, but the numbers are different, this will be considered real numbers. So as long as it's a real number, one, and we're looking at it in both the addition and the multiplication versions of it. A plus 0 would always give me my same A. I never changed the A value, even if I added a 0 to it. Now, I do the same thing now with multiplication. A times 1 equals A. The value still doesn't change. For A, it does not change, and it remains the same. This is for the identity. Next is for inverse. For inverse, we're still following the addition and the multiplication versions of it. So inverse is, no matter what value I do for the addition portion, it must cancel out and equal 0. That's what we're working on for the addition portion. And the multiplication version, we're doing it so that whenever I multiply, it adds up to 1. So let's work on the addition portion. If we take A, once again, as our real number, and we're doing an addition for it, we want it to add up to 0. So what is the best way for it to cancel out? A negative A. We have one A that's positive, one A that's negative. That gives us our 0. For the multiplication version, we have A, and we want it to equal to 1. So the best way we can get it to cancel out and to be 1 is if I flip the A upside down, and that would give me 1 over A. From here, this will make the A's cancel out, and then that will give us our answer of 1. And lastly, we have our 0 property. In our 0 property, this is important because it will allow us to know where our zeros should be applied and how the value of the 0 or the placement of the 0 will change the answer that we get. So we have, once again, in our 0 property in a different color, we'll do multiplication and division for this one. A times 0. We already know anything times 0, and A is a real number, it equals 0. Great. Now, 0 properties also focus on the division portion of it, and our 0 needs to be placed in the right place, or else I'll show you why. 0 divided by A is a simple division. Anything with a 0 is on the top and the real numbers on the bottom, it would automatically give you 0. Now watch this. I'll write this in red. A is our real number over 0. This answer will not give you 0. It will give you an answer, and that answer is called undefined. Because no number should be over 0. Any number over 0 is automatically undefined. 0 over the number will give you 0. A real number divided by 0 gives you undefined. That's it, guys. So that's the quick summary for commutative, associative, distributive, and we discussed in this section the identity, inverse, and the 0 property.